Hello, I'm Anusha Meka, Principal Group Engineering Manager in Microsoft's Azure Cloud and AI organization. Over the past decade, I have had the opportunity to lead engineering teams building large-scale cloud platforms and enterprise AI systems used by millions of users and organizations worldwide. My work has focused on designing highly reliable infrastructure, scaling distributed platforms across global regions, and helping enterprises deploy AI safely and effectively at scale. As more organizations move from experimentation to production with AI, the challenge is no longer just building models. It's building platforms that can support them reliably, securely, and globally. Today, I would like to share 3 key principles for building enterprise AI platforms that scale across cloud infrastructure. The first principle is that AI platforms must be built on strong, resilient cloud infrastructure and architecture. Many organizations focus heavily on models and algorithms, but large-scale AI success actually depends on the infrastructure underneath it. This includes distributed compute systems, resilient storage layers, multi-region deployments, and strong observability across services. When you're operating AI platforms globally, your architecture must support high availability, low latency, and regulatory compliance across different regions. That means designing for redundancy, fault tolerance, and automated recovery from the beginning. In practice, this often involves strategies like availability zones, regional failover, and robust SLO and SLI monitoring frameworks that ensure platforms can sustain enterprise workloads reliably. Without this foundation, even the most advanced AI models cannot operate effectively in real production environments. The second principle is designing AI platforms for elasticity and resource efficiency. AI workloads are extremely dynamic. Demand can spike dramatically as new products launch or enterprise customers scale usage. To handle this effectively, platforms must be able to dynamically allocate resources such as GPUs, compute clusters, and inference infrastructure. This requires intelligent capacity planning, workload scheduling, and elastic architecture that balances performance with cost efficiency. One important factor is optimizing how infrastructure is used. For example, by designing flexible inference architectures and smarter capacity models, organizations can significantly increase GPU utilization and reduce operational costs while still maintaining and meeting performance requirements. At enterprise scale, efficiency is just not a technical advantage. It becomes a major business driver. The other principle is building platforms that empower developers and teams across the organization. A successful enterprise AI platform is just not infrastructure, it's a developer ecosystem. This means providing internal tools, APIs, governance frameworks, and deployment pipelines that allow engineers to build, test, and deploy AI applications safely and quickly. Strong platform governance also helps organizations manage risks such as security, compliance, and model reliability. When done well, this approach allows thousands of engineers and teams to innovate on top of a shared platform while maintaining consistency, quality, and operational standards across the board. The result is faster product development, stronger reliability, and ability to scale innovation across an entire organization. Building enterprise AI platforms at global scale requires more than powerful models. It requires resilient cloud architecture, elastic infrastructure that can handle dynamic demand, and developer platforms that allow organizations to innovate safely and efficiently. Companies that invest in these foundational capabilities will be the ones that successfully move AI from experimentation to real-world impact. Thank you for listening, and I'm excited to see how organizations continue to push the boundaries of what's possible with AI at scale.